Welcome back to Knowledge Hub. Which came first, black hole or galaxy? A team of astronomers conducting a systematic search for supermassive black holes has discovered 3 more of the mysterious objects lurking in the centers of nearby elliptical galaxies. This brings the total number of supermassive black holes definitively identified so far to 20. The discovery was announced at a January 13 news conference in Atlanta during the American Astronomical Society meeting. The formation and evolution of galaxies are intimately connected to the presence of a central massive black hole, said astronomy professor Douglas Richstone, leader of the research team. Radiation and high-energy particles released by the formation and growth of black holes are the dominant sources of heat and kinetic energy for star-forming gas in protogalaxies. Richstone said the team's conclusions are inferred from 2 pieces of evidence. First, all or nearly all galaxies with spheroidal distributions of stars, bulges and spirals, seem to have massive black holes. The mass of these objects seems to correlate with the mass of the central part of the host galaxy. The ubiquity of this association, as well as the correlation, points to a connection between the massive black hole and the galaxy, and poses a chicken and egg dilemma of which came first, Richstone said. Second, comparisons of the history of star formation in the universe with the history of quasars, conducted by other scientists, reveal that quasars developed well before most star formation in galaxies. Quasars are extremely powerful bright objects capable of generating the luminosity of 1 trillion suns within a region the size of Mars' orbit. The massive black holes now seen in centers of galaxies are relics of these quasars, Richstone explained. So these black holes must have been present at the height of the quasar epoch when the universe was about 1 billion years old. To detect the existence of new black holes, Richstone and his colleagues use a computer model to detect abrupt changes in star velocity patterns as stars spiral closer to the galactic center. Input for the computer model comes from Hubble Space Telescope observations and ground-based spectroscopic data obtained at MDM Observatory, which is operated by the Dartmouth College, Columbia University and Ohio State University. The technique was developed by Carl Gebhardt, a former postdoctoral fellow, who is now affiliated with Lick Observatory at the University of California, Santa Cruz. Based on the size of the galaxy and the velocity pattern of stars at the core of the galaxy, we not only can detect the signal from a black hole, we also can estimate its mass, Gebhardt said. Masses of the 3 new black holes detected with the model range from 50 million to 100 million suns, which continues our previously reported correlation of black hole mass with galaxy mass. The team's newest black holes were identified in galaxies NGC 4473 and NGC 4697, located in the constellation Virgo, and NGC 821 in Aries. Stellar orbital distributions in these 3 galaxies are characteristic of others studied with our model, suggesting a common history among all galaxies, Gebhardt said. Other astronomers on the Black Hole Census research team include Jason Pinkney, a postdoctoral fellow, John Magorian, Cambridge University, John Cormendy, University of Hawaii, Todd Lauer, Gary Bauer and Richard Green, National Optical Astronomy Observatory, Alan Dressler and Luis Ho, Carnegie Observatories, Sandra Faber and Alex Filipenko, University of California, Ralph Bender, Ludwig Maximilian University in Munich, and Scott Tremaine, Princeton University. Thanks for watching.